Pandy Knight.
What's up, family? How we doing, PyTexas? My lightning talk, I'm going to talk about BDD. Who here knows what BDD is? What is it? You're wrong. It stands for Bulldog Driven Development. This is my Bulldog. Her name is Suki. She is a French Bulldog. Did you know Frenchies are the most popular dog breed in America? I mean, just look at this thing. She is thick and juicy like a steak. Oh, so cute. My wife and I, this is our first dog. People ask, do you have children? We say no. We have a Bulldog. This is Suki. This is our baby child. In Chinese, we call her Mahaiza, meaning fur baby. She is very much the favorite child of the family. Just, oh my gosh, look at this, having so much fun. Suki gets to travel the U.S. We've taken her down to Jacksonville to see the beaches of Florida. We've taken her down to Savannah to see the beautiful trees. We've taken her to Seattle. These are the spheres in the Amazon district. They go by another name. This is also some park out in the Pacific Northwest. She's an adventure puppy. We love it. She's even been to Buc-ee's. Yes, Suki has been to Buc-ee's. She's having a good time. When she's not traveling the U.S., she's pooking around the house. And yes, pook is a verb, P-O-O-K. I want to turn this picture into like an Andy Warhol print, you know. Sometimes you can hear pictures. Look at her trying to bark. Or sometimes if she's not pooking around the house, she's sitting there silently judging you. She is the master of the side eye. Sometimes she's a grumpy pants. I think her spirit human is Wilford Brimley trying to tell me about diabetes. Sometimes we think she might be a bullfrog instead of a bulldog, but we know that's not true because she doesn't like getting wet. Poor puppy. But at the end of the day, we love this dog. She is our baby. She is a gift from God. Suki the Frenchie has made our lives so much better. Aww. Aww. You know, we're all driven by something. And I know this is a Python conference. We're in a software context. I mean, there's behavior-driven development, test-driven development, data-driven development. I don't know whatever the else-driven development, right? But I think it's important to remember that we make software for humans, and it's important to remember what drives us, right? I'm driven by my family, by my faith, and by my Bulldog. So never forget what drives you to do what you do. Thank you very much, PyTexas. This is Bulldog Driven Development. My name is Pandy Knight. It's been an honor.
Better? Okay. All right. So I'm going to talk about strings. Who uses strings in their Python scripts? Okay, everybody. That's right. Okay. And what I'm going to talk about are a couple of things that you'll find about using strings in your production applications. Strings are everywhere, and they have everything in them. They'll have what you expect. They'll have what you don't expect. They'll have spaces, they'll have character turns, they'll have new lines and so forth. Control characters, sometimes nothing. So there are a number of common less than best practices for working with strings, and I've got 3 of them on this list. And why are they common? They're common because this is what's in the tutorials that you'll find online, because the tutorials are written back in time before some of these newer features are there for better practices with strings. So I'll start with the first one, which is how to remove leading and trailing literals with string, lstrip, and rstrip. Actually, that's the anti-pattern. And for those of you who were here last year, I actually did a lightning talk, and this was one of the slides out of this, so I'm rerunning this, this particular hint. But in this case, we're using lstrip to remove the leading www off of this web address. Unfortunately, lstrip is more aggressive than you think because it's not using a string. That string is actually the list of characters that we're going to remove from the source string. So removing www dot is actually going to give us elsfargo.com. Solution, as of Python 3.9, is to use remove prefix and remove suffix, which now are smarter about removing those segments from the source string. The next one I have is to use string.split to split a string into 2 parts. The first example here isn't really a surprise. It's actually doing what we expect. We want to split on the letter B, and we get everything before and everything after. The variability is that if the B isn't there, we're just going to get a single element list, which has the entire string in it. And in the following two examples, where we give it an empty string or a string containing just a B, we get either a single element or a double element, but we have to have more code. We have to write more code to figure out, was the B even there, and what was in place around it. So for production use, you want something more predictable, and that's partition. With string.partition, you always, well, in fact, there's the advantage. You always get a 3-string tuple, and the center tuple, or the center value, is the separator if it was present, or an empty string if it wasn't. And corresponding R partition, partitions from the right side instead of from the left side of the string. So using partition instead of split gives you more predictable data results, and you don't have to write as much inference code to figure out what it was you were actually working with. The last one is logging string values. And here we have an F string, which is, I have no such value key. In this case, the first example, AABCC, we get a message, no such value AABCC. The second one, our log, just shows no such value AABCC. It's a little hard to see that there's actually a leading space on that key value. And it may be that leading space is why it wasn't found in the database or in the source. The third case is one that I've seen happen in a couple of companies already, where data that was originally passed through as AABCC was colorized by somebody who thought, oh, it will look prettier if I colorize this. And so now I've got an escape sequence. But I don't see that here because I've only printed it as the string value. If instead I log the repr of that value, I get a couple of things. One is I'll get surrounding quotes around the value, and I'll also expand control characters to be more visible and interpretable, and so I don't have to guess, oh, why is it in red, or why does the red value not match? So reprise the log string values. Oh, and by the way, you should double and triple check your messages in your accept handlers, because a lot of times, those don't get logged until the exception happens.
5 minutes.
Okay.
Thank you, Paul.
I have one more slide, which you're going to want to see. This.
Wow. Yeah.
So this, didn't realize I was going to go over, though. As one of the authors in Python in a Nutshell, O'Reilly has given us a discount code, and I have cards that you can have these codes on as well.
All right.
But from Google Play, you get 40% off the online version of Python in a Nutshell.
All right.
Thank you.
Y'all scan fast or see Paul after. Thank you, Paul. That was awesome.
The title of this is Using a Large Language Model with Your Data, Retrieval Augmented Generation RAG in 5 minutes.
I don't think I could read that title in 5 minutes, Will.
Okay, how do I get the right screen here?
You may have to set it to mirror, or you can drag it over, either one. We good?
This is gonna be, I can see it down here. Okay.
All right. Let's get Will.
Okay, I have 5 minutes. So I told you the title. My name's William Horton. I'm a staff MLE at Included Health. You can find me on Twitter. So I'm going to teach you about Retrieval Augmented Generation, RAG. It's a very hot topic. My goal by the end of this 5 minutes is to make you all sound like geniuses, because I'm telling you all your bosses are talking about RAG if they're talking about AI, and it's actually a somewhat simple concept. So I'm going to show you. Okay, so I'm using the Python SDK from OpenAI, specifically chat completions. There's two main parameters. I set my model, and then I send this message. So my role is user, and I have content. It responds to me. Messages is a list, so it can contain your whole history. So I put the model's response into the list. I add a second message. I continue the conversation. I get a not that funny joke. They're still working on that part of AI. Anyway, that's just to show you the tools. That's not the content. So I've written a simple function wrapping that to be able to send one user message to the LLM. So LLMs know a lot. They know some geography. They know math, maybe. They know language, and they know history. This is what we would call world knowledge. It's knowledge that's been baked into the model through training, but they don't always know what we want them to know. What day is it today? I'm sorry, I can't provide that. Okay, thanks, GPT. What is my job title? That would be useful at work. They don't know. Who is speaking at PyTexas 2024? Does it know? No, I'm going to tell you, it does not know. It has no idea. So there's some good news. This is what RAG is about. You can actually just add to the knowledge by telling them new things. Yeah, it really is that simple. People ask me if they can train or fine-tune models using their own data, and the secret is that in today's paradigm with these super large models, people aren't often retraining. What they're doing is just passing more information to the model in the prompt, especially in the system prompt, which is special instructions that you can give to the model. So revisiting the questions above, but with the necessary context. So here you can see I'm sending a system message, and I'm actually telling the model the current time is whatever the current time is when I run this. And the model will actually be able to answer it now. It tells me it's, oh, Friday. That's actually interesting. I did not vet that. That's called a hallucination, everybody. But it knows that it's April 20th. That one I did not catch in prep. Okay, so I've written a second function here, an iteration of my call LLM, where I can now pass in a system prompt. This will give the context to the model. So if I tell it, my name is William Horton and I'm a staff Emily, blah, 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 and then I ask it what is my job title, it knows. And that might seem very silly, but I actually use this at work all the time. I tell it what my job is, and then I ask it to read a document, and it can use that context that you've told it to inform how it responds. Here's another one. I downloaded the HTML for the talk schedule. It's about 35,000 characters. It looks like that. It's all HTML. Now I ask it who's speaking. It's going to take some time on that, so I'm going to move on and come back. So RAG, really what it gets at is, what if we have many documents? So I gave it HTML, but what if it was multiple documents? Well, I want to get the documents that are relevant to my query. Okay, so that worked. This I want to delete. Yeah, here we go. I already created some docs that were all the presentation information. They look like this. They're stringified JSON, one for each talk. I'm going to turn them into embeddings. If you don't know what embeddings are, I'm not going to be able to cover that in the talk. Let's just say they capture something about the semantic similarity of these strings. So each embedding for each talk description will help me figure out how similar it is. There's the embeddings. They're just a bunch of numbers. Oh, go, 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 go. I'm down to less than a minute. Okay, I'm just going to prove that the model does not know this. It would be cool if it did, but I'm sorry, Andy. Python conference famous does not get you into the knowledge of GPT, apparently. Okay, but I can create an embedding for my query. Now, if I have my query embedding and my document embeddings, I'll be able to find the most similar documents. Using some cool NumPy, these are the indexes of the documents that are most similar. How many documents should I get? I chose 3. Models can ignore irrelevant stuff. So I get my context. It's a bunch of strings, and you can see at the top is the actual relevant one about Andy. Now I call it again, and it knows that Andy works at Bloomberg. That is RAG in 5 minutes. It does not work with the wrong documents. You can factor it into a function. All the code I just wrote fits in 17 lines. And if you don't want to write it, use something like LlamaIndex as a framework. Find me on Twitter, on GitHub. I'll post this stuff. Now you can go back and sound like a genius. Just say RAG.
Awesome. Thank you. Al Swigert, ladies and gentlemen.
All right. Hello, hello. Okay, so for the last 2 months, I've been in Brooklyn attending the Recurse Center. What is the Recurse Center? Oh, wow, okay, people have heard of this. Yeah, how I describe it, it's sort of like an artist retreat, but for software developers, and it's great. You go there and you're working on a software project of your own, but you're also surrounded by a bunch of other people who are smart and motivated and also working on projects of their own. They also have a remote option as well, so you don't actually have to go all the way to Brooklyn. I encourage everyone to just kind of check it out. I mean, it sounds sort of weird for me to say it's life-changing, but I've definitely become one of those people who now talks about the Recurse Center and encourages everyone to apply, which is how I got sucked into it. So it's not a cult. But, so the Recurse Center has a code of conduct, of course. But one thing that I found really interesting was it also has 4 social rules. And these are rules that, unlike the code of conduct, they actually kind of expect that from time to time you're going to accidentally break these rules. These rules are really great. It's given me this language to talk about things that I've noticed before in social situations, but I didn't really know how to describe. So here's the 4 rules. The first one is no well actuallys. This is probably one that people can understand. It's basically when somebody makes a statement and then somebody else butts in and says, well, actually, with something that's, it might be technically correct, but it's not really relevant, and it kind of just derails the entire conversation. So in these cases, right here, it's like, hey, I just installed Linux on my computer. And then somebody else says, it's actually called GNU Linux. It's like, okay, yes, thank you for that information, but it kind of just like disrupts the whole thing. And this sort of thing, again, it's not a big deal. This is, from time to time, we'll all do this because we're all excited about the knowledge that we have, and we want to share this knowledge, including correcting other people. But it is like this kind of like tiny death by 1,000 paper cuts thing. And so basically somebody can then say like, oh, well, hey, you're doing the well actually thing. And you can say, oh, sorry, yeah, I didn't mean to do that. The next one, no feigning surprise. This is a big one. I was once at a monthly tech meetup and we were talking about the X11 Windows system for Linux. Hands up if you know what the X11 Windows system is, okay? And now hand up if you've never heard of this before. Right. Some of you have, some of you haven't. There was one person who just said like, oh, yeah, what is that? And the other person who was talking to him said, you've never heard of that? And I want to say, like, it really doesn't take much to make a person feel unwelcome at a space, especially when they're at a technical conference or some meetup and they're already really afraid that they don't know enough or they're somehow like not qualified. And it can be really just little comments like this, like feigning surprise, that can really just drive people away, actually. There's a lot to do in life, and there's more to life than Python. People can just say like, well, maybe tech isn't for me, and I'll just do something else with my life. So no feigning surprise. No backseat driving. That's another one. This is where you have added information, but you're not really part of a conversation. You just kind of like throw this little tidbit into the discussion, and again, it derails and disrupts the conversation. Okay, I'm running out of time. No subtle isms. Okay, so things like harassment and discrimination, those are covered by the code of conduct. Codes of conduct are not optional. The social rules, though, these are things where, like, yeah, from time to time, unfortunately, we might break some of these rules. So the example here is, oh, Windows is hard to use. It's like, no, Windows is easy. My mom can use this. And that's like the subtle racism, sexism, ageism, these things that can also make people feel incredibly unwelcome. So no subtle isms. And, there's a lot of like room for judgment calls on what technically counts as a violation of this. But the general idea is that you want to make a space where people feel welcome, where they're not going to be, psychological safety, I feel, is the main word for this. It's really important to have in organizations. You want to be able to tell bad news to your boss. You want to be able to view your coworkers as people you're cooperating with rather than competing against. You want everyone to feel like they can contribute without being negatively impacted. Anyway, I'm running out of time, so Google this, the 4 social rules at the Recurse Center. Thank you very much.
Nicely done.
All right, hello everybody. My name is Peter, and this talk is called So You Want to Give a Talk? 5 ways to keep your audience off their phones. You might have seen me up here just about 4 hours ago. This is what it looked like. If you remember me, hi again. I'm going to talk about 5 rules up top here. The first one is be engaging. Then the second one is be loud. Third one is be big. Fourth one is be prepared. And the last one is be considerate. I only have 5 minutes, so I'm going to rush through. But all 5 of these you can remember with this handy acronym. Just LBPK. All right, let's start at number 1. Be engaging. So this is all about making sure that your audience is on board with your talk. You start by introducing yourself. Then you start by introducing your topic after that, which I just did. Then you get to the point, which hopefully I'm doing right now. The point about all of this is that your audience is going to quickly lose attention if you go off on a tangent or start to fiddle with your laptop a little bit, or you're not really sure what's going on there. When you are telling your story, it's really handy to use a very classic story structure like this. You can start with exposition. Here's the problem I want to solve. Here's the rising action. Here's all the interesting stuff you want to know about. Here's the climax. Here's the falling action. Here's the resolution. It's all just telling a story. But make your audience familiar with the problem before showing them the solution. Don't start with how you solve the problem before they even understand why they care. Another thing that I use to be engaging, I use presentation software like Keynote. That's my favorite. I use this all the time. I'm using it right now. And I use a concept called object constancy, which you just saw there. I'll do it again because it's really cool. You do transitions and all this kind of stuff. You add more things to the slide, and then as things move around on the slide, you make sure that they stay visible. You never fade something out and fade it back in. You never put it off the screen and then pop it back on. And that animation seems like it's just sugar on top, but it's really handy to help your eye track that and keep it in view. I use this feature called Magic Move to do that. It's built into Keynote. You should use it. It's really easy. And also, speaking of transitions, even obnoxious transitions can be useful for dramatic effect. If you really want to make a point, use something really, really visually catchy to get people's attention. Speaking of getting people's attention, be loud. I'm currently speaking into this nifty device called a microphone. It looks like this. It's got a couple parts to it. It's got a pop filter on top. You can hear that because I can pop the filter by really doing that with my mouth. It's got a capsule underneath, which is picking up my voice and actually transmitting it to the speakers. And it's got a body that you hold on to. There's a couple ways you can use a microphone. You can speak directly into it like this, and you can hear that's very loud, very clear. I hope at the back you can hear that, maybe. Excellent. So I would say this is a good way to use a microphone. You can also use it like this, vertically underneath your mouth. That's okay too. However, there is a slight downside here. If I exhale with my nose, you can hear that. So holding it horizontally kind of avoids that problem. What I would not recommend is doing this or doing this. Doesn't really work that well. Even having it up here and then kind of speaking off to the side, you need to be right on it. People say that they eat the mic sometimes, and that's not a misnomer. You can get really up close there, and it sounds loud and clear. Okay, one other thing I want to talk about is being big. What do I mean by that? Well, that text is big. All text on slides that I put up must be at least 60 points in size. That text is 60 points. It's pretty easy to read, I hope, but at the back, if you've got, I don't know, not the best vision like I do, that's hard for me to see. So 120 points is also pretty good. Usually I go as big as I can. This text is 240 points. That's even better. Make it as big as possible. Don't waste a single pixel on your slides. You've got extra space there. Why would you waste it? The bigger you can go, the more people that can actually read your content. Also, don't show me the window Chrome if you can, please. There's no need to have all of that extra space there. I don't need to see the other slides that are coming up next. That will distract me. Also, sometimes it's very useful to not show anything at all, right? If I'm talking to you and I really want to engage with you and tell a little bit of story, there's nothing I need to show on the screen. There's nothing you want to read at the same time. I'm not going to hold the last slide up there. That's not very useful. I hope you're listening to the words I'm saying right now instead of being distracted by the last slide that was on the screen. And also, side note, don't forget to turn off notifications. Very, very important. I've got 30 seconds left, so I also want to say be prepared. Run your talk over and over and over again. I ran this just sitting there probably 3 or 4 times before giving this just now. If you're doing a live demo, that is presenting on hard mode, just fake it. This looks like it's real. It's not. It's part of Keynote too. Gotcha. And finally, be considerate of your audience's time. 1 second of time wasted times 60 audience members is 1 minute of time wasted. Blah, 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 blah. You don't want to waste people's time. So that's all I've got. Be engaging, be loud, be big, be prepared, and be considerate.
Wait. Before you drop the mic, confirm something for the audience. We have not spoken before this.
No, we have not spoken before this, no.
Okay, keep that in mind.
Before Josh starts,
All of you laugh.
I do want to say, Raghu and Aaron, if y'all want to kind of line up over here so y'all are ready next.
Okay.
If you haven't seen enough of this guy yet, you're going to see more of him.
You're going to see more of it. I'm going to do my best to gesticulate wildly. Okay, 5 quick short tips for presenting your ideas, which I give to like interns and stuff like that all the time. Rule number 1 is tell a story. Stories have a beginning and a middle and an end. So stick to a story. Have a narrative. Have a path that you're taking the users on. Tip number 2 is find your signposts. Take your story, split it up into parts. Those signposts are the spaces between the different parts. Those are time for you to stop and if you're doing a more interactive presentation, it's time to take questions from the audience. But either way, it gives you a distinct section so you can kind of gauge the room and figure out where you want to go next. Tip number 3, practice, practice, practice. Practice your presentation multiple times. Know where your signposts are. Know about how long it takes for each of the different sections. Know which sections you can skip if you're running out of time. Know which sections you can skip if you're losing the audience. Number 4, energy you give is the energy you get. If you don't sound excited about your topic, the audience won't be excited about your topic. So if you're excited about something, feel free to gesticulate wildly. I'm really excited about this library that I'm talking about. Yay! It gives the audience permission to be excited just like you are. And the 5th tip is expect and prepare for the unexpected, especially if you're doing a live demo. The live demo gods are fickle, and we never sacrifice enough USB drives to make them happy. So make sure that you have backup plans. If the internet's out, if the projector doesn't work, you should be able to interpretive dance your presentation if that's all you have available. And there you go. Mercifully short. Wow.
Hello, everyone. Yep. Yeah. I'm Raghu. I'm a mechanical engineering background, and I just wanted to introduce Panel, a dashboarding library in Python. So why Panel or why interactive visualization? So I got into Python mainly because of like the interactive aspect of visualizations in general. Mainly because like if you want to describe complex systems, it's very tough for the end user to understand what is the underlying physics behind the system. So what we do is like try to build interactive web applications so the end user can toggle various aspects of the widgets and try to understand the system. So later I'll show some examples and you can understand. And why you would like to explore Panel is like, I think, how many of you use Matplotlib? And you understand like Matplotlib is not interactive in nature. But by using Panel, you can make your Matplotlib plots interactive. And within Panel, you can basically build plots in Bokeh, Matplotlib, Plotly, Seaborn, Altair, and combine everything into one. So here, for example, is like a k-means cluster. And you can see like you can interact with the features and change the number of clusters and interactively see how the system works. And Panel also interacts with chatbots. For example, like an end user does not need to know Python at all, and he can basically talk to a chatbot and build plots. So he can also, he or she can also like ask the plots to be changed from Matplotlib to Bokeh or Plotly, or any backend can be switched easily. And so how do I use it in my work? So I work for Pratt & Miller. It basically is, our main background is in motorsports, and we have a driver-in-the-loop simulator. It's basically $1 million video game. And what we are trying to do is like describe the vehicle, how the vehicle physics which runs on this particular hardware. And what we are trying to do is understand like develop testing, which basically is easy for the end user or our simulation engineers to see what is working, what is not working. So one implementation in Bokeh is a static HTML report, which is generated to compare like if any developer makes any change, he can quickly understand like what is going on wrong in which aspect of the model. So it basically generates a report comparing signals related to the develop branch or the production branch, and you can generate interactive plots in static HTML and try to see like where the error is generated. One other implementation which we have implemented is in STEM education. So this is actually being used in chemical engineering curriculum at Lehigh University, and this is basically assignments for students to understand chemical engineering. So I get like you need to communicate physics or engineering education in different ways for different folks so that they can get a better idea of what is going on. So here, this is like a sequential reaction of A going to B going to C, and a student can basically, sorry, I need to refresh. So, let's see, hopefully, yeah. So a student can play with the parameters, and a professor or faculty can design assignments basically to get students to understand like how the system behaves. So we have many examples of different simulations. So we have like infectious disease model, which was motivated by COVID, and they can understand like underlying epidemiological models. And we have data science digital lab twin model. And one of the other things is like this one is how to build a zero energy cooling chamber. So without access to electricity, how you can preserve food for a longer time. And this one is teaches thermal physics, and so basically
5 minutes.
You can basically update.
All right, here we go.
Okay. Hi guys, my name is Erin. I'm currently a master's student at UT Austin studying data science. Thank you. Before becoming a full-time student, I was working at TaxAct, which is TurboTax adjacent. We all just filed our taxes recently, so I'm sure we know what that is. But I was noticing that with a lot of business processes, we would build models and then have to integrate them and retrain a lot of models. And so when I took reinforcement learning, I noticed that this type of learning is much more seamless with what businesses tend to do. And I kind of wondered why more businesses didn't do it. I think it's just novel. People aren't as familiar with it. Actually, out of curiosity, raise of hands. How many people know what reinforcement learning is? Okay, there you go. So more people than I thought. Just to intro for those that didn't raise their hand, it's generally considered the third paradigm of machine learning. So along with unsupervised, supervised learning, it's kind of the third type of learning. It's generally made up of, so what I have on the screen, this is a article I wrote on a hands-on project I did with implementing an RL system and optimizing customer engagement with an online tax filing system. So the way I structured the problem and the way most reinforcement learning problems are structured, you have an environment, which in this case is our online tax filing system. Then you have a reward, which you create, and you create this reward so that an agent is incentivized to do the thing you want it to do. So in this case, we want to keep customers from leaving our website. Then you have states, actions, and then, okay, there we go. You have your agent, which I mentioned previously. So those are your 5 main parts of your RL system. So with this system, the actions I used were recommending an upgrade to your customer when they seem frustrated or pausing, having targeted incentives like offering discounts, having a chat pop up with personalized recommendations, and then progress tracking, which TurboTax uses, and it has proved to be helpful with customers when they know this isn't going to take forever, it's going to take 2 hours. It's very motivating. So next, looking at algorithms that you can use, I think if you know reinforcement learning, you might have heard of Q-learning. It's kind of the most popular reinforcement learning system or algorithm out there. So that is a type of temporal difference learning. The other major type of temporal difference algorithm is SARSA. So the difference between those two, Q-learning is off policy and SARSA is on policy. And one big recommendation our professor made was that Q-learning can be very aggressive because it's off policy, whereas SARSA tends to find a more safe policy. And what I mean by that is, with this system, we start from a place where we take no action, and then we're moving towards taking more and more action. You find that as you interact more with the customer, they tend to like that support and want to stay. But as you can imagine, with a more aggressive algorithm, if you're constantly getting pop-ups and recommendations, it can kind of get annoying. So you have to be careful with that. For that reason, I opted for SARSA. And I opted for the temporal difference lambda algorithm, which layers on eligibility traces with SARSA. So I kind of explain all the intricacies of why I chose all these algorithms later on. If you're interested, this article is on my Medium blog. But the takeaway, what we end up doing here, in like 50 lines of code, we're able to automate finding the best action for a user given a certain state. That's what these temporal difference algorithms do. They find the most valuable state action pair, and you're able to use this system to learn dynamically and recommend the best state action pair. So there you go.
Excellent.